Good morning, good afternoon. We're going to be doing Unit 6, Lesson 3 today, Reasoning about Context with Tape Diagrams, Part 2. So we did Part 1 yesterday, and we're going to build upon that knowledge. These tape diagrams are just kind of setting up the foundation of what equations look like and mean in terms of a picture. So let's see how equations can describe tape diagrams. 3.1 says find equivalent expressions. This is kind of a warm-up problem that is a monster. So it says select all the expressions that are equivalent to 7 parentheses 2 minus 3n. That's like saying what is 7 times 2 minus 3n? And explain how you know each expression you select is equivalent. So if that is 7 times 2 minus 3n's, it's kind of wanting 7 2 minus 3n's. The way I could rewrite this is 2 minus 3n plus 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 2 minus 3n. Let's see, there's 1, 2, 3, 4, 5, 6. I need one more, plus 2 minus 3n. That is 7 2 minus 3n's. If I wanted to draw a tape diagram, I guess I could just go ahead and draw it. That's this tape diagram. That is 7 2 minus 3n's. There's 7 of them. So there's a short way of writing that is I just say 7 times 2 minus 3n. So we need to pick number 1, 2, 3, 4, 5, or it says to select all. So I'm guessing there's going to be more than one correct answer. So one way we could look at this is I've got a positive 2, I've got another positive 2, another positive 2, another positive 2, another positive 2. If I add all those together, I got 2, 4, 6, 8, 10, 12, 14. So I've got 14. So right now 2 and 3 are looking good, but not sure. I also have, let's use a different shape, minus 3n, and minus 3n, minus 3n, minus 3n, minus 3n, minus 3n, minus 3n. I have 7 minus 3n's. That's like saying, what is 7 times minus 3n? Well, a minus 3 and a minus 3 is a minus 6, plus and another minus 3 is 9, 12, 15, 18, 21. Or, guess what? That's equal to a negative. I have a negative 21 n's. So I've got 14, and I've got negative 21 n's. So guess what? I keep saying that word, guess what? That means 3 is one of the answers. Is there another correct answer here? I kind of blocked. I'm going to have to erase some of this so I can see the original equation. There it is. 7 times 2 minus 3n. Looking at that, I don't think that can work. We know that can't work. 2 minus 3n times 7. Well, that's just saying this times this. That's up backwards. It's like saying 2 times 3 is equal to 3 times 2. So 7 minus 2 minus 3n, or sorry, 7 times 2 minus 3n is the same as 2 minus 3n times 7. And number 5 is saying like 7 times 2, well, that's 14. 14 minus 3n will not get us the right answer. So it looks like it's just 3 and 4. All right. Pause this video if you have to take a break. Think about that for a second or rewind it. Otherwise, we're moving on. 3.2, matching equations to tape diagrams. So there are 1, 2, 3, 4, 5 tape diagrams. Down here, There's 1, 2, 3, 4, 5, 6, 7, 8, 9 equations. Each one of these equations goes with one of these tape diagrams. So, equation A, let's see. This is the same as saying, what is, don't do that. 5 plus, excuse my 5s look like S's. 5 plus X plus X. Guess what? That equals 19. Let's see if that's down here. Does anyone see 5 plus X equals 19? No, I do not. So maybe we're doing something different. Maybe we need to look at this and say, wait a second, let's see if we can abbreviate. How about 5 and this is the same as 2x's is equal to 19. Is that down here? I don't see that, but I do see a 2x plus 5, which is the same as 5 plus 2x. So let's write A next to that one. 2x plus 5 equals 19. That's not the same as, is that the only one that works? Let's look. I don't think it's that one. I don't think it's this one. 2x plus 5, I don't see that. Oh, I do see 19 equals 5 plus 2x. These two are the same, believe it or not. 19 is the same as 2x plus 5, or 5 plus 2x. 2x plus 5 is the same as 5 plus 2x, just like saying 3 plus 2 is the same as 2 plus 3. So those two, I believe, are the two correct answers here. All right, let's take a look at, there might be another one. Let's see. Let's look at B. What the heck is going on? Maybe I'm looking at this backwards. Here is another 2x's, and we're adding a 5, and that also equals 19. So B is looking awfully similar to A. Maybe we need to rethink this. A is 5 plus 2x. So maybe this 2x plus 5, maybe this needs to be B. So forget that. Maybe that one goes with B. 2x plus 5 equals 19. So I spoke a little early. Let's look at C. Here I have 2, and I have 1, 2, 3, 4, 5 x's. That's like saying 2 plus 5x. 2 plus 5x's is equal to 19. Is that down here? 2 plus 5x is equal to 19, right there. That is C. That's the next one. Those two go together. Is there any others down there that might work? Here's one way you could look at this. Take a look here. You might not know this. Well, we'll come back to it. We'll see if you guys can figure out. There is another one that goes to. And if you want, pause it and see if you can figure that out. We'll come back to that, though. Letter D, I have x plus 5 and I have x plus 5. So I look down here. Do I see x plus 5 plus x plus 5? No. It doesn't say that. What that actually means, though, is I have 2 x plus 5s. I have 2x plus 5s. Or you could say, and I don't know if it's going to do this, but there's an x and there's an x. There's 2 x's, and there's a 5, and there's a 5, which is 10. That's also equal to 19. Guess what? This equation and this equation are the exact same thing. So let's see. 2x, 2 parentheses x plus 5. I do see that right there. That one is D. And let's see if I also see 2x plus 10. Did I see 2x plus 10 anywhere? No. Oh well. All right. There might be another one with this one as well, but let's look at E. Here I have 1, 2, 3, 4, 5x plus 2's. So I write it like this. I have 5x plus 2's. Remember, repeated addition is multiplication. So that's like saying x plus 2 plus x plus 2 plus x plus 2 plus x plus 2 plus x plus 2. Or 5x plus 2's is equal to 19. So that's E. 5x plus 2's is equal to 19. So that one goes with E. Now, unfortunately, there are 1, 2, 3, 4 more equations that go somewhere. So I see x plus 5 times 2. Hopefully that rings a bell and you notice that's the same as 2x times x plus 5. 2 times x plus 5 is the same as x plus 5 times 2. So that one is also D. And then hopefully you'll notice 5 times x plus 2 is the same as x plus 2 times 5, which you'll see. This right here and this right here are the same. They both equal 19, so that one must be E. Now come the whoppers. I've got 19 divided by 2 equals x plus 5, and I've got 19 minus 2 equals 5x. Well, if you want, pause this and see if you can figure out which one this goes to. There's 2 equations. I'll give you a clue. One of those equations goes with A, B, C, D, or E. And the other one goes with A, B, C, D, or E. So I narrowed it down for you. And if you're looking closely, I'm going to erase some things here. Look what's happening here. If I wanted to solve this, if I said, hey, what do you think x could equal here? Well, step 1 is I'm going to get rid of this 2. And if I get rid of this 2, if I get rid of it from there, if all of this equals 19, if I get rid of that, well, guess what? I'm going to get rid of 19. And now I have 5x's. There are 5x's. That's equal to 19 minus 2. So if you look down here, C is actually that one. 19 minus 2 is equal to 5x's. So kind of tricky to see. Now this other one, maybe you saw it already, maybe you didn't. I'm going to erase it so we have some space, but if you can't already guess what I'm erasing, this one must go with D. But if you look right here, I've got 2x plus 5's. If I cut this in half, then 1x plus 5 is equal to half of 19, or what we say is 19 divided by 2. If I cut each side in half, then half of that whole thing is equal to half of 19, and that goes with D. So there, look, 19 divided by 2 is equal to an x plus 5. And if you're getting this, guess what? You are going to get 8th grade math. But this is not the first and last time we'll be doing things like this. So we've got a match for each one of those equations. It does say sort the equations into categories of your choosing. Explain the criteria for each. So if you looked at all those, I bet you could come up with 1 or 2 categories, or actually 2 or 3 categories. You have any ideas? If you're thinking what I'm thinking, the most obvious categories would be some of these, like this one, this one, this one, this one. They all have parentheses, and some of them don't. And that's worth noting. It makes a big difference if they have parentheses or not. All right, let's look at 3.3, drawing tape diagrams to represent equations. 114 equals 3x plus 18. 114 equals 3 times y plus 18. Draw a tape diagram to match each equation. And then, however you want, use any method to find x and y. Or in other words, what must make it true? What do I need to plug in? What would I plug in for x? 2? That means 3 times 2 equals 6. Plus 18, does that equal 114? We'll get to that. But as of now, first we're going to draw a tape diagram. So first and foremost, I see 114. So I know my whole tape diagram is going to equal that. But I do see 3 x's. So I'm going to go 1, 2, 3 x's plus, and my tape diagram might not be to scale, plus 18. That's an x, that's an x, that's an x. I have 3 x's. And all of that's going to be equal to 114. So there is my first tape diagram. Now, let's go ahead and just solve that. So I know that something plus something plus something plus 18 is going to equal 114. Yeah, something plus something plus something equals that. Well, if all 4 of these things equal 114, if I got rid of this 18, and if I got rid of 18 from 114 as well, that's going to leave me with, I don't have a calculator out, but that's going to leave me with 96. 96 is going to leave me with, let me write it over here. That's going to leave me with 3 x's. So I got rid of the 18. Essential first step. In fact, we're going to practice this a lot. It's essential. So I got rid of the 18, and I got rid of 18 from the 114, which means there's 96 left to equal 3x. Well, if 3x's equal 96, I want to cut that 96 into thirds. If 3 of them equal 96, well then, what does 1x equal? Saying, well, I got 96, and I want to split it 3 ways. I want to split that 96 3 ways, and that means, equals, guess what? X equals 32. Now this 114 equals 3 times y plus 18. Well, that means I've got 3 of those. I've got a y plus 18. I've got a y plus 18. And I've got a y plus 18. 3 of those. That's equal to 114. So, how are we going to solve this now? 3 of those is equal to 114. By the way, there's a lot of ways to actually solve this. There's a lot of ways. But one way is to say if 3 of these is equal to 114, if I split 114 3 ways, if I divide 114 3 ways, how many times does this 3 go into 114? I like to just test out my old math skills. It's 38. So guess what? This is 38. This is 38. And this is 38. So guess what? Y plus 18 equals 38. If that's the case, if I've got a y plus 18 and all of that's equal to 38, that should be 18. If I get rid of 18 and I get rid of 18 here, you might recognize this. How do I solve that? Well, the inverse of 18 is I need to add a negative 18. So 38 minus 18, and I get 20. Y equals 20. And if we look at that, 20 plus 18, plus 20 plus 18, plus 20, all of that will equal 114. There is another way to solve that. we could go ahead and count this. There's 1, 2, 3 y's, and there's 18 plus 18 plus 18. That's 18 plus 18 is 36. 36 plus 18, I believe, is 54. Yeah, that'd be 54. You could say all of that is equal to 114. We could get rid of the 18, get rid of that one, or get rid of 54, and then split the rest of that 3 ways. That's definitely a way to do it. In fact, we're going to practice it both ways. But for right now, well, for right now, we should start to know both ways. But we got a lot going on there. If you're listening, if you're trying to fast forward and write this down, sorry about that. That's not going to make a whole lot of sense. So, moving on. Tape diagrams, solved it any way we could. And boom shakalaka, what is this thing appearing at the bottom? And how do I get rid of you? Cross my fingers, got lucky. So here's a summary. It's going to break it down a little bit for you if this is still a little confusing. Although there is a good step right here that explains everything that's going on right there. I have 4x plus 9s, or I have x plus 9 times 4 equal to 76. And one way we could say is we're going to take the 76, split it 4 ways, like they're doing that, and what that's going to equal one of those x plus 9s. And then we're into the one-step equations that we're used to solving. So that was lesson 3. And now we're going to look at some lesson 3 practice problems. So, are any of you familiar? I'm looking at those boxes down there. If you're maybe some of you are familiar with Sudoku, or watched your parents or grandparents do Sudoku, or somebody. That's kind of what that is down there. I know my brother-in-law loves these Sudoku things. So anyway, number 1, solve each equation mentally. I'll help you with this last one, but it's kind of saying, well, 1/3 times what? Be paying attention to positives and negatives. First off, I know letter C is going to be positive because a positive times a positive. So 1/3 times what is 6? Or 1/3 of what is 6? Well, 1/3 of 3 is 1. This is kind of like saying 1/3 of something, remember, is like taking a number and dividing it by 3. So what divided by 3 is equal to 6? And if you remember, the way we solve this is I want the inverse of 1/3, which is actually what times 1/3 equals 1. We want to times each side by 3. So actually, what would I do here? I'm timesing each side by 3. And guess what? There's our answer. And you're going to do the same thing with letter D. And you're going to think to yourself, I got a negative times what is a negative? Well, I know x must be a positive number. And this is kind of like saying, well, half of what is 7? And I'll let you figure that out from there. It says complete the magic square so that the sum, that's addition problems, the sum, not multiplication, addition, don't write it slanted, otherwise you'll think it's multiply. The sum of each row, each column, and each diagonal are all equal. And if you notice, well, that one's different. These means everything's going to equal 9. Here, it looks like everything's going to equal 9 as well. But apparently this one is just 6. So we want them to all equal 6. And the way you do these, guys, is you plug in a number and it works, and then you have to move it around and you're like, whoops, I got to move that number there. Oops, I got to move that number there. So I'm not going to ruin the fun for these, but I do know if these are equal to 6, then 4 plus a negative 1 is 3. 3 must go here because we now get it to equal 6. I have this equaling 9, so 5 plus a negative 2 is 3, which means that must be 6. And you just have to do trial and error. You just have to do trial and error. If this is equal to 9, then 7 plus 3 plus what also equals 9. And I'll leave you. I don't want to ruin the fun. Let's look at number 3. Draw a tape diagram. And doesn't even say how we have to solve it, which is fantastic. Draw a tape diagram to match each equation. So do number 3, A and B on your own, and then hit pause, do those, then unpause it, and let's see how you did. This is essentially like saying x plus 1, I've got 5 of them. One, two, three, 4, 5. And all of those, I'll write it up top so I have extra room, is equal to 20. And you could even solve that if you wanted to. Maybe you could guess what that is. 5 times what is 20, so x plus 1, what plus 1 is equal to that number, and you could probably figure it out. But the next one, it says 5x's, which is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Plus 1. All of that is equal to 20. So the first thing I would do to solve that is I would get rid of 1. And then I would get rid of 1 and then get rid of 1 from the 20. And then I would split that number among 5. You'd have a fraction, which isn't a big deal. And your answer would be 19/5 or 4 and something. Number 4, select all the equations that match the tape diagram. So I can see 1, 2, 3, 4, 5, 6 x's and an 8 equal to 35. Boom, that's the first one. Next one, 1, 2, 3, 4, 5, 6 and an 8. Boom. 6 x's and an 8 is equal to 35. There's another one. And is that the only one? If I got rid of this 8, if I took it off, and I took off from here, that means all of that is equal to 35 minus 8. 6 x's is also equal to that one there. And then finally, number 5, each car is traveling at a constant speed. 5 the number of miles each car travels in 1 hour. So in order to get miles per hour, you just take the miles and divide it by the hours. So 135 divided by 3, and you'll get your answer. And guess what? You do the same thing for each one of these. What's 97 and a half divided by 3/2? Well, a lot of work going on here. First thing I have to do is, sure, I could get out my calculator, and this would be like 97.5 divided by 1.5. That works. By the time you get all that out, I could probably have this figured out mathematically. 97 halves. That means how many halves is 97? Well, I do the buying. That reminds me to do 97 times 2. So I double 97. What is 97 doubled? 97 times 2 is 194. So I have 194 halves plus one more half. Plus one more half. So I have 195 halves. So now I do keep, change, flip. And we could say 195 doubled. By the way, I can switch these, but I could switch these. In other words, make this 2 over 2 equals 195 over 3. And I'll do it both ways. What the heck? But either way, 195 doubled, 200 doubled would be 400 minus 10 would be 390. Oh, I should show my work. I'm doing, 195 times 2 over 2 times 3, which is 390 over 6, and that's going to equal something. And I'll let you figure that out. But you pretty much do all the rest of this. B, C, and D are all the same. There is shortcuts. Like on this last one, guys, when I did 195 over 2 times 2 over 3, if I switch this, because 195 times 2 is the same as 2 times 195. So if I switch those, I get the same answer. But notice I'm left with 2 over 2, which is just 1. And 1 times this is, so I'm left with just a slightly easier number to use than this. Those are the same. And you're going to notice if I switch them on this one, it's going to make my life very easy. In fact, I can look at that knowing that I'm going to do keep, change, flip, and switch them. I can look at that and know my answer. But let's call it good. If you like this, if you hated this, if you kind of like this, if you kind of hated it, hit that like and subscribe. You see it right there? Yep, just click it. And that's it for now. Peace. Okay, I had to say that quiet because my baby's sleeping upstairs.